Today's video is about Bohr diagrams. There are several different models of the atoms that we are studying, but the Bohr model is the most widely used because it is simple enough for most people to understand, but it still has enough detail to get the basic knowledge about the structure of the atom. 3 easy steps. If you look at your note sheet, you'll need note sheet number 13 and a periodic table. The first step is to write the number of protons, and this is the same as the atomic number. So you look at your periodic table, you find the atomic number, and you'll write down the number of protons. Step 2 is to draw the energy levels. So these are the circles around the nucleus. Remember, it's not an actual circle or a track that the electrons follow. It's just the idea that there is an area in the empty space that surrounds the nucleus where the electrons live. The number of energy levels is determined by the row number that the element is in on the periodic table. So the top row is 1, the second row is 2, the third row is 3, and so on. Step 3 is to draw the electrons. This is the same as the atomic number, so however many protons you counted, that's going to be the same for the number of electrons, assuming that it is a neutral atom. The electrons fill in the lowest energy levels first. So they fill up energy level 1 before they fill up 2, before they fill up 3, before they fill up 4. And we are going to mainly be dealing with the first 3 energy levels. Remember from our notes on the structure of an atom that the first energy level can hold up to 2 electrons. The second energy level can hold 8 electrons. And for our intents and purposes, the third energy level can hold 8 electrons. The electrons also tend to form pairs, so they tend to not hang out alone, but they pair up if they can. So step 1 is to write the number of protons. So we look that up on the periodic table. So we're going to do 3 examples. We're going to look up hydrogen, nitrogen, and aluminum. So hydrogen, we find the atomic number is 1. Nitrogen, the atomic number is 7. And aluminum's atomic number is 13. So what you are going to do, you can see in the box on the right-hand side of your note sheet, there's already a 1p and a 7p, and you are going to include a 13p. Make sure you put that somewhere down towards the bottom left corner so that you have plenty of room to draw the energy levels around it. Step 2 is to draw the energy levels. So take a minute to look at your periodic table and find the row number that hydrogen, nitrogen, and aluminum are in. You can pause the video if you need to find those. Hydrogen is in the first row. Nitrogen is in the second row. Aluminum is in the third row. One of the most common mistakes here is that people don't count the very first row that has just hydrogen and helium in it. So make sure you count that very top row. So now what we're going to do is go back to our box on the right, and we're going to draw in circles around the 1p, 7p, 13p. So since hydrogen it's in the first row, it has 1 energy level, so we draw 1 circle around the nucleus. Nitrogen, 7p, has 2 energy levels, so we draw 2 circles around the nucleus. And aluminum had 3 energy levels, so we're going to draw 3 circles around that nucleus. We're almost done. Step 3 is to draw in the electrons. Remember, this is the same as the atomic number. for a neutral atom. So however many protons you labeled is how many electrons you're going to draw. So hydrogen has 1, nitrogen has 7, and aluminum has 13. Remember, they fill up the first energy level first, so the closest to the nucleus. The first energy level can hold 2, the second energy level can hold 8 more, the third energy level would hold the next 8, and they tend to form pairs. There is a specific order that they tend to fill up. There is a specific way that they tend to form pairs, and I'm going to show you that way, but for the most part, as long as you get the correct number in the energy levels, you're going to get credit. So in the first energy level, they form one pair. So the first electron and the second electron go in the first energy level and pair up. It's not uncommon to see those separated, but this is the way that they do actually form up. And in the second and third and energy levels after that, they tend to form pairs. The first two form a pair, then the third, fourth, and fifth each get their own space until the sixth will have to pair up, the seventh will have to pair up, and the eighth will have to pair up. But again, as long as you get the correct number in the energy levels, I am not going to be as concerned as the order in which you fill them up. If you take chemistry, then you will learn more details about why this happens, and you will be held accountable for the correct placement. So let's go ahead and finish our 3 examples. 1 proton means 1 electron, so it just goes in the first energy level. 7 protons for the nitrogen means that the first 2 will go in the first energy level. And then we need 7 minus 2, we need 5 more. So those 5 electrons go in the second energy level. Again, as long as you get the correct number, 5 in the second energy level, you'll be given credit. And then in 13p, which is aluminum, the first 2 electrons go in the first energy level. Then 13 minus 2, we need 11 more. So we will put 8 electrons in the second energy level. And that shows how they would fill up. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. We need 3 more. Those will go in the third energy level. Again, the first 2 and in each energy level tend to pair up. So 1, 2, 3. Step 4 is to enjoy them. They are that simple. Look at the periodic table for the number of protons and electrons, which is both given by the atomic number. The row that they're in tells you the number of energy levels, and you fill in 2, 8, 8. Now you try, pause the video. In the space at the bottom of your note sheet, there is a list of elements: helium, lithium, sulfur, fluorine, and argon. Go ahead and try to draw the Bohr models for each of those. If you are listening to the video, put a star in the bottom left corner of the note sheet underneath your helium atom. And then here are the answers. Helium is 2p, so we have 2 electrons in the first energy level. Lithium is 3p. It has 3 electrons. It's in row 2, so we write the 3p. We put the first 2 electrons in the first energy level and the third electron in the second energy level. Sulfur is 16p, so we draw the 16p. Sulfur is located in the third energy level, so we fill up the first energy level with 2 electrons. We need 14 more. So 8 go in the second energy level. That's 10. So we still need 6 more electrons to balance out the protons. So we put 6 in the third energy level. Fluorine is 9p. It's located in the second energy level, or the second row. So the first 2 electrons go in the first energy level. That leaves us 7 electrons in the outside energy level. And argon is 18p. It's in the third row, so we have 3 energy levels. And this one has 2 in the first energy level, 8 in the second energy level, and it completely fills the third energy level with another 8 electrons. One of the things we see from the Bohr model is the number of valence electrons each atom has. Remember, valence electrons are the electrons in the outermost energy level that actually contains electrons. So there are 2 valence electrons for helium, 1 for lithium, 7 valence electrons for fluorine, 6 valence electrons for sulfur, and 8 valence electrons for argon. The back of your worksheet is your remaining practice. There are 9 more Bohr models to draw. The first 5 you are given the energy rings, but the last 4, make sure you look at the periodic table. And when you are done with that, you'll have a quiz.